Okay, today we're going to learn about radical expressions, and radical expressions are going to be represented with this kind of a symbol, that radical symbol, kind of like a square root. The only difference is instead of just having a square root, you could have a cube root. All depends on the number right here, which is called the index. So most of these you've seen before. Sometimes you'll have cube roots, sometimes you'll have fourth roots, and we'll see what we're going to do differently for each of those. Just some basic vocabulary. We've got the index, which is the number above that shelf right there. You also have the radicand, which is anything inside of our radical symbol, and the coefficient is the number in front. But make sure you don't confuse the coefficient with the index. Just a couple of rules before we get started in simplifying radicals. You can't have any negative radicands, which means you can't have any negative numbers inside of the radical. You can have them outside, just not inside. So if it does have a negative inside, there's two different ways that you can simplify it. If you have an even index, so that number on the shelf is even, like 2 or 4 or 6, then you can move the negative outside and it changes to an I right there. If it's an odd index, so a 3, a 5, a 7, then instead of having the negative inside the radical, you move the negative outside the radical, and the inside becomes positive. So you have to make sure your final answer doesn't have that negative inside of the radical. Okay, the other rule is you can't have a radical in the denominator of a fraction, which only comes up a few times. We got to make sure we know what to do if that happens. So if you have that, like this example right there, let's zoom in on that. See how there's a radical underneath? We can't have that. You can have it on top. That's fine. You just can't have it underneath. This is the one that's in trouble. So to get rid of it, we look at just the radical part, so that radical 6, and we multiply it to the top and the bottom. And the top, you just multiply the inside numbers. So that 5 and 6 makes radical 30. Bottom, 6 and 6, you have a pair of radical 6's, which makes the radical go away. And then, if you can, try and simplify the top if possible. So that radical 30, if you could break it down, you would simplify that. But this one doesn't break down. So let's get into how we simplify the actual numbers in the radical. So the first thing you're going to want to do is, if you have any numbers, okay, inside the radicand, so that's that inside part, then you're going to want to make that prime factor tree that we did in our starter today. And you're just trying to get it to be the form of this. Something times something times something. You can do the same thing with the variables. So we break it up. If we have x to the 5th, that means we have 5 x's. If we have y to the 2nd, we have 2 y's. So we write it out so we have everything times each other. And then you look at the index to determine how to simplify. So that's that number on the shelf. If that number is not even given, it's automatically a 2. So like a square root, we assume that number is a 2. If that number is a 3 or 4, then we're going to group things differently. But we are going to group up these numbers. And you're looking for numbers that are the same. Okay, so like here we have quite a few 2's in our example, and our index, let me highlight that here, the index is a 3, which means we're looking for 3 of a kind. So we have 4 2's, so we can group 3 of them up, because they're the same number. Same with the x's, we can group up a group of x's, and there's another group of 3 x's. So you look for as many groups as possible, but there's no other 2's to group up, 3's or 5's. So those guys have to stay there. If you look at the next page, once we do have those groups, then we're going to move one of each group outside. So we had a group of 2's, we had a group of x's, and we had another group of x's. So that's why one of each of those is moving outside, where the coefficients are. And if there's any coefficients that are already there, they do stay. And then just make sure that after you've checked for any groups and you've moved them, we just simplify the numbers outside and the numbers inside by multiplying. So this example that we just had, we have 2 and then x squared because there's 2 x's. Keep that 3 on the shelf, and then 2 times 3 times 5 is 30. And that would be what the final answer we're looking for is. So let's look at problem 1. In problem number 1, the index is not given, which means that it's automatically a 2. We're looking for groups of 2. So go ahead and find your prime factor tree. We have 10 times 18. You might have done something different there. That's okay. You'll have the same prime factors in the end. We get 3, or sorry, that's not a 3. 2 times 9, 3 times 3, and we write it out. So in this example, we have 2 times 2 times 3 times 3 times 5. There's no variables. We do want to make sure that we're writing it in number order so we can see those groups easier. Now go ahead and figure out what groups we have. Remember, we're looking for groups of 2, so 2 of a kind. Okay, we have a group of 2's and a group of 3's, but the 5 doesn't have a pair, so that stays. And when we rewrite it, we take a group of 2 outside, we take a 3 outside, so just remember one of those because we're simplifying. And then that 5 had to stay in the radicand. And our final answer, that 5 doesn't simplify anymore, but the 2 times 6 does, or 2 times 3, which gives you a 6. Okay, that would be our final answer, so we're going to box that up. Problem number 2, do the same thing we did in our starter. First, though, we want to make sure we can simplify the bottom. We don't want to multiply that huge number if we don't have to. So go ahead and do your prime factor tree and simplify that radical 63 and write the simplified version. Oops, let's see, write the simplified version right here. So simplified, this is going to be 3 radical 7. And the top, we can simplify that more so we don't have to work with a big number. Go ahead and try simplifying the top. And you're going to write that right here. Okay, the top, when we simplify it, is going to be 27 radical 3. Because we had a pair of 3's that moved outside with the 9. So now, we're going to take a look. We've got that 27 radical 3. We've got that 3 radical 7. We only have to multiply whatever radical's on bottom. Here, it is a radical 7. And you just do the same top and bottom because as long as you multiply it to the top and the bottom, it's as if you're not changing the whole fraction. And then we multiply the insides. So we get 27 and radical 3 times radical 7 gives us radical 21. And then the bottom, when you multiply 2 radicals that are the same, the radical goes away. So we get 3 times 7. And then, if you can, try and simplify this. So 27 has a 3 in it. Remember, that's 3 times 9, technically. So those can cancel. And we get 9 radical 21 over 7 as our final answer. Okay, go ahead and start the problem number 3. Now notice here, this is where we have that negative. So remember, if it's an odd radical, or odd index, the negative needs to move outside right away. Keep that 3 on the shelf. And then go ahead and do your prime factor tree and figure out how to simplify 112. Okay, you should get -6 cube root. We have 2 times 2 times 2 times 2. Make sure you don't forget any. And you're only looking at the ends. So this is an end, 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 end. You don't want to use the numbers that are breaking down more. So we have 4 2's, we've got a 7, and we have 5 x's. They're all under the radical. And here we are grouping in sets of 3. So go ahead and circle any sets of 3 you have. Okay, you should get one here and here. And there's no other sets of 3 of a kind. So we move the negative, or we move the 2 outside with the -6 and an x, because you only take one of each group. We still have that cube root, and then we have 2 times 7 times x left. And we just simplify, and that is timesing, not 27. So we get -12x cube root, make sure that 3 stays on the shelf, 14x squared. And that is our final answer.